Okay, dear students, in today's class we'll discuss about the color and the colorless ions. To understand this particular topic, first you should know how to write the electronic configuration. Then you should know elements from 21 to 30. Then maximum questions related to this particular topic can be solved. So let's see how to write the electronic configuration. You know it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2. With the help of this configuration, we can write the electronic configuration for 2 plus 2, 4, 10, 12, 18, 20, 30, 36, 38. For 38 electrons, we can write the electronic configuration. Now, let's see the atomic number 21. You know, element with atomic number 21 is scandium. So here 21 means it is a 2, 4, 10, 12, 18, 20. 20 plus 1, 21. So from 3D, out of 10, we need to take 1 electron. So it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. So it is the 2, 4, 10, 12, 18, 20, 20 plus 1, 21. In the same way, if you take the iron, you know iron atomic number is 26. So here 26 means 2, 4, 10, 12, 18, 20, 20 plus 6, 26. So out of 10 we need to take the 6. So here it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So 2, 4, 10, 12, 18, 20, 20 plus 6, 26. Now, let's see the chromium. You know chromium atomic number is 24. So if you take the 24, so it is the 2, 4, 10, 12, 18, 20, 20 plus 4, 24. So generally how do you write here? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Generally we write like this. But you know, here in the s subshell we are having the 2 electrons, and in the d subshells out of 5 orbitals we are having the 4 electrons. Now you know it is unstable. If the electron from here, if it jumps here, then this is stable as well as this is also stable configuration. So here instead of writing the 4s2 3d4, we write this one as 4s1 3d5. So it is stable according to the Hund's rule. So it is somewhat different than expected. That's why here this one is most important. In the same, if you take the copper is 29. So 29 means 2, 4, 10, 12, 18, 20, 20 plus 9, 29. So generally how do we write? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. It is expected, isn't it? So 2, 4, 10, 12, 18, 20, 20 plus 9, 29. But you know, here in the s2 electrons, okay, it is stable. But if you take the d orbitals, here we are having the 5 d orbitals in which we have the 9 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now unit is unstable. If all are half filled or completely filled, then it is stable. So if the electron from here, if it excites here, then this is half filled configuration stable. It is full filled configuration, it is stable. So here the configuration changes to the 4s1 3d10. Now, so here this is the configuration which is other than expected. That's why it is important. So chromium and copper, these two are important. So here these have the configuration other than expected. Okay, dear students, let's set the electronic configuration for ions. For example, if you take the ferrous Fe2 plus, you know iron atomic number is 26, configuration is 1s2, 2s2, 2p6, 3s2, 3p6. Now, here we have to remove the electron. When we have to remove the electron, you know the electrons are removed from the last orbit. So what I do, I write the last orbit last. For example, 1s to 2s to 2p6, 3s to 3p6, 4s to 3d6. So it is a 2, 4, 10, 12, 18. Okay. So 18, 20, 26. So 26. According to Aufbau principle, it should come first, it should come next. But as we are removing the electron, I have written like this. How many electrons we have to remove? 2 electrons. So we remove the 2 electrons from here. So when you remove the 2 electrons, so we don't have any electrons here. If you take the 3d, we have the 5d orbitals. So here we have the 5d orbitals. So in this 5d orbitals, we have the 6 electrons. So 1, 2, 3, 4, 5 and 6. Now you can see here we have the unpaired electrons. So whenever we have the unpaired electrons, then it is colored. So whenever we have the unpaired electron, then that is a colored. Now, for example, if you take the scandium 3 plus, you know scandium atomic number is 21. So configuration. So 21 can be written as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. So it is a 2, 4, 10, 12, 18, 20, 20 plus 1, 21. Again, according to Aufbau principle, it should come first, it should come last. But as we have to remove the electron, the last orbit I am writing last. So here we have to remove the 3 electrons. We remove the 2 electrons from here, 1 electron from here. So here we don't have any electrons now. Okay, now if you take the 3p, in this 3p, we have all the paired electrons. Here we don't have any unpaired electrons. So as we don't have any unpaired electrons, it is colorless. It is colorless. In the same way, for example, if you take the Cu number 29, we take the one positive charge. Now, here electronic configuration. For 21, we write 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d10. So 2, 4, 10, 12, 18, 18 plus 1, 19, 19 plus 10, it is a 29. You know, again, according to Aufbau, it should come first, it should come next. But as we have to remove the electron, from last orbit we remove the electron, that's why the last we are writing last here. So here we need to remove how many electrons? 1. So the 1 electron is removed from here. So 0. Now if you take the 3d, in this we have 10 electrons. So 10 electron means all are paired. All are paired means no unpaired electrons. No unpaired electrons means it is also colorless. Okay, let's solve the previous NEET question. They're asking in which of the following pairs both the ions are colored. So they are saying colored. Both means both should be colored. Like for example, either this or this or this. Both should be colored. Both should be colored means both should have the unpaired electrons. So let's see where the unpaired electrons are there. For example, if you take the scandium, you know scandium atomic number is 21. In the beginning of our session itself, I said you should know the elements from 21 to 30 perfectly. Okay, so you should know the name and number. Okay, scandium number is 21. So configuration is 1s2, 2s2, 2p6, 3s2, 3p6. Then here 4s2, 3d1. Okay. Now here 3 plus means 3 electrons are lost. 3 electrons are lost means 2 from here, 1 from here. Means here no electrons. And if you take the 3p6, here 1, 2, 3, 4, 5, 6 means we don't have any unpaired electrons. No unpaired electrons means it is colorless. They are asking the colored. So obviously it is not the colored, means it is colorless. So this is not, means of course this option is wrong option. Let's directly go to the next option. Here also the same we will get. Here also scandium given, here also scandium given. So it is also not the color. Now let's take this one. Nickel. You know nickel number is 28. So here 28 means it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. So here plus 2 means we need to remove the electrons from here. So 0 electrons. 0 electrons means we can ignore this one. So here in this 3d we are having the 8 electrons. In 5d orbitals we have the 8 electrons. We have the 2 unpaired electrons, means it is colored. Let's check whether this is also colored. titanium. You know titanium atomic number is 22. So 22 means configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. So 2, 4, 10, 12, 18, 20, 22. So 22. Then we need to remove the 3 electrons. 3 electrons means from here 2 electrons, from here 1 electron. So 1 electron is left, here the 0 electrons. Now in 3D, we are having 1 electron. So 1 electron is there, unpaired electron is there, means it is colored. So means this option is right. So like this, we can solve the questions easily. Okay, now let's solve the previous JEE question. They are asking in which of in following pairs the one in which both transition metal ions are colorless. They are asking colorless. Colorless means there should be no unpaired electrons, or else there should be paired electrons, or else vacant orbitals. Let's see. Let's take this one. You know zinc number is 30. So 30 means configuration here is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. We have to remove the 2 electrons. So from the last orbit we remove the electron. So here when you remove the electron, here you will have the 0 electrons, and if you take the d, here in this d we are having all the paired electrons, means here this is colorless. Okay, so it is colorless. Now let's take this one also. If you take the manganese, you know manganese number is 25. So configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. So here we have to remove the 2 electrons. 2 electrons means we remove from here. So we don't have any electrons here in this 4s now. In this 3d we have the 5 electrons. So here we have the 5 unpaired electrons. And you know if there is even a single unpaired electron, then that is a colored. Now it is colored. Colorless, colored. But what they are saying, both should be colorless. So this is the wrong option. Let's take this one. If you take the scandium, so here if you take the scandium, you know scandium number is 21. So configuration 1s2, 2s2, 2p6, 3s2, 3p6, then 4s2, 3d1. So 2, 4, 10, 12, 18, 20, 20 plus 1, 21. We need to remove 3 electrons. So 2 electrons from here, 1 electron from here. So here 0, here also 0. Now here earlier to that we have all the paired electrons. So there is no unpaired electrons in this. So it is colorless. If you take the zinc, here in the zinc, you know zinc number is 30. So the same sequence we need to write here. That is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. So we have to remove the 2 electrons. When you remove the 2 electrons, here we don't have any electrons. In this 3d, you are having all the paired electrons, isn't it? You have all the paired electrons. Now there are no unpaired electrons, or there is no unpaired electron. That's why it is colorless. So both are colorless. So both are colorless means it is right. So both are colorless. So like this we need to solve the question. Hope you understood all this. Okay dear students, all the best all of you.